Alright guys, power is the last topic we have to talk about, and of the different topics we've discussed this unit, I think this is one of the easier ones. So hopefully this video is nice and quick. First, let's talk about why we need power. Let's pretend we have Charlie and Lena, and both of them are going to push on a box with a force of 20 newtons for 3 meters. Using this information, we're going to be able to figure out how much work they do. Okay, so the work Charlie does is 20 newtons for 3 meters, which would equal 60 joules. And then we take a look, and the work Lena does would be the same because she's applying the same force for the same distance. But does it matter to us that it only takes Charlie 3 seconds, but it takes Lena 45 seconds? Probably. I mean, that's showing that Charlie is doing the same amount of work a lot faster than Lena. But how do we show this? With the equations that we currently have, we can't. And that's where power comes into play. Power is simply going to be work divided by time. So when we write it, it'll be power equals work over time. Power is going to be measured in watts, and as we know, work is measured in joules, and time, of course, is measured in seconds. So let's go back to our example where Charlie and Lena both pushed on a box with a force of 20 newtons for 3 meters. Remember, we know that each of them, the work, was 60 joules. The work of Charlie, the work of Lena. But now we can see Charlie only uses 3 seconds, Lena uses 45. So let's figure out their power. Power, remember, is work over time. We know that here we have power equaling, for Charlie, 60 joules divided by 3 seconds, which would equal 20 watts. Over here, for Lena, we know the power is going to equal work divided by time as well. The power equals 60 joules. The time is 45 seconds. And so Lena only has a power of 1.33 watts. Now we can see a difference between the two of them based on the fact that one took more time to do the same amount of work. Charlie is going to be much more powerful. Now, a lot of times we hear about power in terms of horsepower, and it's a real thing. Basically, when we went through the Industrial Revolution, we were creating cars after that. People were tentative to buy a car because they knew how powerful their multiple horses were, and they had no idea how a car would compare. So they converted the power of an engine into the equivalent of a horse. So they could say, oh, this car is the equivalent of 3 horses. Well, now we are up to cars that have 335 horsepower, which is a lot of horses. But when we talk about this, it's just a conversion out of watts. We are going to know that 1 horsepower is equal to 746 watts. So if I told you a car had 335 horsepower, how many watts of power does it produce? We would simply say, okay, I've got 335 HP. I'm going to multiply that. I know my conversion factor here is, I want to put my 1 horsepower on the bottom so that those will cancel, and that's the same as 700. I don't know where that 5 came from. 46 watts. We multiply across, and that will be 249,910 watts. And that's all there really is to power. Tomorrow we'll do a couple demos that involve this. We'll talk about it a little bit more. My cat Kenya wants to say hi. So I'll see you guys tomorrow. Hopefully this makes sense. Let me know if you've got questions, and don't forget to fill out the survey.